Hello friends, in this video we are going to talk about the various algorithm which is used for intra as well as inter Piconet scheduling. So let's begin with the topic. Piconet is basically a concept that comes under Bluetooth network. Bluetooth is basically a personal area network that comes under the wireless technology. Wireless technology uses RF signal for transmission of the information. In case of Bluetooth, maximum 7 devices can be connected to one master in one Piconet. Now, in case of Bluetooth, the maximum range that can be covered is nothing but 10 meter to 100 meter, and that will vary depending upon the user's requirement. In Bluetooth, it is possible to join or leave the network at any time without having any complex setup. Bluetooth is very easy to implement, and therefore it is most widely used standard in wireless PAN network. In wireless PAN network, the three standards are used, and the standards are: first is IRDA, which uses infrared for transmission of the signal; second is Bluetooth, which uses RF signal for the transmission of data; and third one is IEEE 802.16 standard. But out of these three, Bluetooth having more advantage, and it acts as a foundation for the third standard, that is IEEE 802.16 standard. At the same time, it eliminates the need of line of sight which is required in case of IRDA. Therefore, Bluetooth becomes more popular and most widely used standard in case of wireless PAN network. Basically, a PAN network consists of a very small area and it covers a very short range distance, and therefore it is called as personal area network. Depending upon the user's need and depending upon the user's requirement, the PAN network can be established anywhere as per the user's requirement. The examples of the PAN network are nothing but the home automation, then office automation, then a network present in building or a campus can be considered as an example of PAN network. Now in this topic, we are going to talk about how the synchronization is achieved within a Piconet and in between the two Piconets. When one or more than one network, or when we can say when one or more than one node forms a network, then it forms a Piconet. A simple example of Piconet is nothing but the two Bluetooth enabled devices communicating with each other. In Bluetooth network, the device which originates the communication or the device which initiates the transmission is called as master, whereas the other device who receives the message is called as slave. So when two devices get connected with each other, one device acts as a master, another device acts as a slave. In one Piconet, we can connect maximum 7 devices to one master. When master wants to leave the network, it can leave the network, and any one of the slave can be acts as a master. We can connect more than 7 devices in one Piconet, but the additional device will act as a part of the network but do not actively participate in the communication. It has the ability to only listen what communication is going on onto the network. If the additional node wants to be an actual part of the network, then it requires to swap with one of the active slave. If master leaves the network, then any one of the slave can act as a master. In case of Piconet, one or more than one node can be used to form another Piconet and can act as a master for that particular Piconet. When two Piconets communicate with each other, then it forms a scatternet. So now let's start with the inter-Piconet scheduling. Now, in case of Bluetooth, polling gate differs from classical polling in the transmission form from the master to slave is always combined with corresponding slave to master transmission. That means the transmitter between or the transmission between the master and slave is get combined with the transmission or data transfer from slave to master, and therefore master has only partial such status knowledge of the slave, while it only knows its own queue. That means master having the knowledge of only its own queue, and it do not have, or we can say it has a partial knowledge about the status of the slave's queue. Therefore, classical polling model cannot be directly used in case of Piconet, or we can say classical polling model cannot be used in case of intra-Piconet scheduling, and they can still used as a benchmark. Now in case of SOC Link, the master has to poll the slave at regular interval. That means the master has to check the status of every poll at regular interval by using a scanning cycle, given a straightened requirement of this type of traffic. Therefore, for SOC Link, the master device does not have much freedom to use one of the other scheduling algorithm. It only requires to perform the polling, and it do not have the freedom for using any of the algorithm. In case of ALC link, that is for asynchronous connection link, polling can be performed in many different ways, and we focus only on the scheduling for ACL link only. So in case of SOC, there is a restriction on the master that it cannot use more than one algorithm for performing the polling operation. But here in case of ACL link, it is possible, or the freedom is given to the ACL link to use more than one algorithm for performing the polling of various slaves present in the network. Now let's discuss the first type of algorithm, and that is nothing but limited and weighted round robin scheme, which is also called as ElWR. So it is basically adopts a weighted round robin algorithm with weights being dynamically changed according to the observed status of the queue. So by determining whether the queue is ideal or queue is busy, depending upon that, here the algorithm is get dynamically changed as per the queue status. ElWR consider the activeness of the slave. In case of Bluetooth, there are 4 modes of operation, and the device can work in that modes of operation. And the 4 modes are: first one is active mode, second one is hold mode, third one is park mode, and fourth one is sniff mode. So on the basis of in which mode the slave is in, depending upon that, the algorithm is get changed dynamically. Now in this case, initially each slave is assigned with a certain amount of weight. For example, here we are considering the weight value is W, which is reduced by 1 each time a slave polled and no data exchange. So every time when the master scans the poll, so after every interval or after every regular scanning, the value of W is get reduced by 1, and in this case no data exchange takes place. Therefore, the slave misses many chances in the polling cycle, as is the difference between its current weight and W. So as the value of weight is get reduced, therefore there may be a possibility that the slave misses many chances for the data transfer after every regular interval of the scanning cycle. Lowest value that the slave's weight can achieve is 1. Its meaning is it has to wait with a maximum of W-1 cycle for sending a data. So the minimum value, the value of weight cannot be reduces to 0. The minimum value is nothing but 1, and the maximum value is nothing but W-1. So only when the weight of the slave is having a value of W-1, then only it is possible for the slave to perform a data transfer. Anytime there is a data exchange between the slave and the master, the weight of the slave is reset to a W value. So whenever the master observe that the slave having certain data for the data exchange, then it performs the data exchange in that particular scanning cycle, and at that time the value of weight is again resetted to the original value of W. In this way, the polling of, or we can say the data transfer between the slave and master takes place by using ElWR algorithm. The pseudorandom cyclic limited slot weighted round robin protocol, or we can say algorithm, is another type of algorithm which is used for inter and intra Piconet scheduling, and it is denoted by PlWRR, and it is based on the 2 main properties. The first property is it tries to distinguish between the slave on the basis of their activeness, that is according to the traffic history, and PlWRR reduces the rate of polling to less active slave by not polling them for a certain number of slots. Now in this case, depending upon whether the device or whether the slave is in active mode or whether it is in hold mode, park mode or sniff mode, based on that the slaves are get distinguished in this type of algorithm. And here also the rate of polling is reduces after every polling cycle. Now in this case, the certain number of slots are appointed, or we can say the certain number of slot is bound for the maximum time between the poll to slave. So here the slotting is done on the basis of the activeness of the slave, and the same activeness is used for differentiating between the 2 slaves. The second property by using which the PlWRR algorithm work is the order in which the slaves are polled in each cycle is determined in a pseudorandom manner so as to improve the fairness, and has been shown to provide a certain degree of fairness and perform well on the scenarios with the different traffic source like TCP and CBR. So now here, rather than going sequentially, the polling occurs randomly. So because of that, it is possible to provide equal chance of data exchange to each of the slave, and therefore the channel bandwidth, or we can say the polling, can be done in a fair manner with giving equal chance to each of the slave. Now here, PlWRR basically consists of two parts. The first part is a pseudorandom cycle of polling, and second is a limited slot weight round robin algorithm. So the algorithm, that is PlWRR, is basically combination of two different types of algorithm. The first algorithm is nothing but the pseudorandom cycle of polling, which is used for providing scanning cycle not in a sequential manner but in a random manner, because of which each slave and master can have an equal chance of data exchange. And the second method of algorithm is nothing but limited slot weight round robin algorithm, in which a weight value is assigned to every slave, and for every scanning cycle the weight value is reduces. Only when the data exchange between master and slave takes place, at that time the value of W is get resetted to its original value. So by combining these two algorithms, the algorithm of PlWRR is get formed. The next type of polling that we are going to discuss is nothing but the fair exhaustive polling. The fair exhaustive polling, which is also called as FEP, is viewed as a combination of the strict round robin polling and the exhaustive polling. So here also we are considering two algorithms. First is round robin algorithm and second one is the exhaustive polling algorithm. The main idea is to poll slave that probably have nothing to send. So the slaves which are having ideal condition, or we can say the slaves which are in hold mode, are used here for the polling purpose. The fair exhaustive polling achieve this by introducing two complementary states, namely active state and the inactive state, and also by associating weight with each slave. So here the devices get distinguished by using the two states, and the states are nothing but active and inactive, and for every state there is a value of weight assigned to that particular slave. Now, in case of fair exhaustive polling, the polling cycle starts with the master moving all the slaves into the active slave, and then initiate one of the several possible polling subcycle once in a round robin fashion. That means here initially all the device becomes an active participation, and after that the polling takes place in case of round robin manner. One distinguished feature in FEP is that the master performs the task of packet scheduling for both the downlink and for uplink data transfer. That means here the packet scheduling or the packet data transfer takes place from master to slave as well as from slave to master, which was not possible in the previous case. The master has only limited knowledge of the arrival process at the slave, which means that the scheduling of the uplink flows has to based on the feedback it obtains from the polling of the slave. As we know, in case of round robin algorithm, the master only having a partial knowledge about the queue status of the slaves. So because of that, the scheduling of the uplink flow has to be done on the basis of the feedback received from the slave. So by using that scheduling, it is possible for the master to perform uplink and downlink packet scheduling. The next is nothing but the predictive fair poller. It is another method which is used for performing a polling from master. It is denoted by PFP. It is a polling scheme that takes both efficiency and fairness into account, similar to ElWR and FEP. As we know, in case of ElWR, the random polling takes place, and because of that it is possible for every slave to get an equal chance for data exchange. So similarly here also efficiency and fairness, that means equal chance for the data exchange as well as efficient data transfer takes place by using predictive fair poller algorithm. For each slave, it predicts whether the data is available or not, and while at the same time keeping the track of its fairness. That means the master first check whether the slave having data for the data transfer or not, and it will make sure that each slave get an equal chance or equal opportunity for the data sharing purpose. So based on these two aspects, it decides which slave to poll next, and in the best effort case, PFP estimate the fair share of resources to each of the slave and keep track of the fraction of this fair share that each slave has been given. So here, by checking whether the device having the data for transfer or not, master provide equal chance to each of the slave. At the same time, it will determine which poll or which slave is required to poll next on the basis of the feedback that it receives from the slave device. So that keep track of fraction of these fair shares to each of the slave. Now PFP distinguish two different types of traffic, and they are the best effort and QoS based. Now in case of best effort traffic, the PFP keeps a track of both, that is fairness based on the fraction of the fair share and the prediction, and thus can guarantee to poll the best effort in fair and efficient manner. So here the fair chance as well as efficient data transfer is achieved by using the best effort traffic. The another type of traffic that is supported by the algorithm is nothing but the QoS based traffic. So now in case of QoS based case, QoS requirements are negotiated with the slave and translated into fair QoS treatment, and the polling unit in turn keeps a track of the fraction of these fair QoS treatment that each slave has been given. So rather than providing a complete QoS, or rather than providing a full QoS or fulfilling the full QoS requirement of the slave, there will be a negotiation between master and slave on the QoS requirement, and based on that requirement, the fairness or QoS requirement is achieved by performing the polling. The next is nothing but the demand-based Bluetooth scheduling. Now, a flexible polling scheme is proposed that initially adopt a common polling periods for all the slaves and subsequently increases the polling period for those slaves with less traffic load. So here we can say, as its name indicates, demand-based Bluetooth scheduling. So it is basically a flexible polling scheme, and that is proposed, or we can say that is get initially adopted as a common polling period for all the slaves. So if there are 5 slaves are present in the network, then the common polling period is selected for all the 5 slaves, and then the slaves which are having less traffic, for those slaves the polling period is get increased. Similarly, the to other scheme, the idea here is to poll slaves that probably have to send as little as possible. Ultimately, the goal is to maximize the throughput and to reduce the overall Piconet power consumption. So basically, in case of all the types of algorithm, the main thing or main goal achieved is to provide the maximum throughput, that means the maximum output data transmission rate, and to reduce the power consumption of the Piconet, so that if the devices are using in the Piconet are portable or battery operated, then they can be work for the longer period of time and they can increase the battery life for the years. So basically, the demand-based Bluetooth scheduling is a new type of scheduling method or new type of polling scheme, and that is basically based on the factor that is called as scheduling table. So first, a bridge node and the synchronous slaves are scheduled. So in case of scheduling, first of all, on the basis of the demand, bridge node and the synchronous slaves are get scheduled first. After that, the asynchronous dedicated slaves are get scheduled. So on the basis of the priority and on the basis of the table, the scheduling for each node is done. Now, when we talk about the inter-Piconet scheduling, then we require to consider 3 different algorithms, and the algorithm or the scheduling scheme are: first is distributed scatter-net scheduling algorithm, that is denoted by DSSA. Second is pseudo-random scheduling scheme, that is denoted by PCSS, and third one is locally coordinated scheduling, that is denoted by LCS. Also, there are various types of algorithm and various type of scheduling technique other than these 3 are used for performing the intra-Piconet scheduling, and the various algorithms are flexible scatter-net wide scheduling, FSS. Second is credit-based scheduling, that is denoted by CBS. Third is local adaptive algorithm, LAA, and the next is jump mode based scheduling algorithm. So by using this algorithm, it is possible to perform the inter-Piconet as well as intra-Piconet scheduling. Now let's move on to the first type of algorithm that is used for the intra-Piconet scheduling is nothing but the distributed scatter-net scheduling algorithm, DSSA. So basically, DSSA provides a conflict-free access to the shared medium, which can be anything, which can be a RF signal or it can be a wireless medium. DSS is based on the assumption that the node having a distinct identity, which is called as ID, and aware of the identified and the traffic requirement of their neighbor. So in this case, it is assumed by the master that the nodes which are present in the network must be aware about the neighboring node properties, and they aware also about the traffic requirements of the neighboring node. In DSSA, each master needs the permission of all its neighbors to schedule its Piconet. So when we talk about the scatternet is nothing but the combination of the Piconet. So here, when one Piconet master wants to perform the scheduling of the Piconet, then it required permission for all its neighbors. That means permission for all the neighboring masters. Once the permission is granted from the neighboring masters, then the master which is with the highest ID among these neighboring masters have scheduled their Piconet. So after taking the permission, the master, as we know, the scatternet is nothing but the combination of the various Piconet. For example, if we are considering 4 Piconet forms one scatternet, so in this case, the master which is having highest ID number, that Piconet get permission for scheduling their Piconet. The DSSS is an ideal algorithm as it assumes that the nodes are aware about the traffic requirement of their neighbors, which cannot be realized in real scenario. In practically, it is not possible that the nodes are aware about the traffic requirement and the IDs of the neighbor node. So as the traffic requirement changes after every operation, therefore it is not possible for the neighboring nodes to aware about that neighboring node's traffic requirement. So this scenario is not practically possible. The next is, in addition to the given requirement, that is the solution carried out from the highest ID master to the lowest ID master, not all the master devices are treated equally. That means only the master which is having highest ID can get a chance for the Piconet scheduling, but the lower masters, or we can say the masters which is having lower ID, do not get a chance for the scheduling. Therefore, there will be no fairness in the process. Then the second type of algorithm that is used for the Piconet scheduling is nothing but pseudorandom scheduling algorithm or pseudorandom scheduling scheme, which is denoted by PCSS. So different from the hard scheme of the DSSS, the pseudorandom scheduling scheme falls in the category of the soft coordinate scheme, where the nodes decide their presence in the Piconet based on the local information. So the disadvantage, or we can say the drawback of the DSSS is get overcome in case of PCSS. Now in this case, the nodes which are present in the Piconet get an equal chance for performing the synchronization or get an equal chance for performing the scheduling, and they decide their presence in the Piconet on the basis of the local information. By nature, the soft coordination scheme cannot guarantee the conflict-free participation of the bridge node in the different Piconets. They will have much lower complexity than the hard coordinate scheme. So here the Piconet synchronization is considerably less complicated as compared to the Piconet synchronization occur or Piconet synchronization takes place in case of DSSA algorithm. So in case of PCSS algorithm, the coordination is achieved by using some implicit rules of the communication and without actually performing the explicit exchange of information, or we can say the explicit exchange of control information. Now, because of the low complexity and because of the compatibility with the current Bluetooth specification, it is easily possible for the algorithm to perform in coordination with the Bluetooth specification. Now here, in case of PCSS algorithm, every node randomly chooses a communication checkpoint, and that is calculated or computed on the basis of the master's clock and the device, or we can say specifically the slave's device address. So by using these two parameters, the checkpoints are get calculated, and that checkpoints are get randomly calculated for the polling scheme. Now moving towards the next type of polling or next type of algorithm is nothing but the locally coordinated scheduling, which is denoted by LCS. So there are certain conflicts present in PCSS algorithm. Therefore, the locally coordinated scheduling scheme is used where the coordinate nodes in manner that they eliminates the scheduling conflict. So the conflicts, or we can say the drawbacks of PCSS scheme is get overcome in case of LCS method or LCS algorithm. In response to the bursty traffic on the link, LCS adjusts both intervals between the communication event and the duration of those events. So by adjusting these two parameters, that means by adjusting the duration of the event and by adjusting the interval between the communication event, it is possible to manage, or it is possible to respond the bursty traffic on the link. The PCSS changes only the interval between the communication. So this drawback of PCSS is get overcome in case of LCS scheduling or LCS algorithm. The LCS based on the concept of scheduling meeting, and that meetings are called as appointments, and optimize the overall efficiency of the scatter net in terms of the output or in terms of the maximum data transfer rate, which is called as throughput. Then it is also get calculated in terms of latency, that means the delay occurs in the communication process, and energy, that means how much power consumption is achieved by using this method. So by minimizing the wastage and missed communication opportunity, so because of this analysis of the various parameters, it is possible to reduce the chances of missed communication and also possible to reduce the wastage. It also provides the various node, or we can say the trade-off between the energy efficiency and the latency. That means here the energy conservation and delay occurs in the communication process are also considered as a major parameter. Now, LCS can only be applied to loop-free scatternet topologies, and LCS achieved high TCP throughput, low packet latency, and low node activity time, which corresponds to low energy consumption for low bandwidth application. So basically the local scheduling or local coordinate scheduling algorithm are used in the application, for example home networking, where we, or home automation or office automation, where we do not require high data transfer rate, or we do not require the high bandwidth requirement. So in this type of network we can use LCS algorithm. Also it provides the low energy consumption, that means less requirement of power is used over here, therefore it is suitable for this type of applications. But it also considers the low packet latency, that means it reduces the delay which occurs during the transmission and reception of the data or packet information. At the same time it provides high throughput, that means maximum data transfer rate. So basically LCS can be used for those environment where these requirements are get fulfilled. The next type of scheduling algorithm is nothing but flexible scatternet wide scheduling, and it is denoted by FSS. Now it basically consists of two algorithms. The first one is a flexible traffic scheduling algorithm executed by a master, and the adaptive switch table modification algorithm, and that is executed by each bridge node. So by combining these two algorithms at master and at bridge node, or we can say at slave, we can perform a flexible scatternet wide scheduling. Basically bridge node is the node which is present between the two Piconet, so that the two Piconet can communicate with each other through that bridge node. So that bridge node executes the adaptive switch table modification algorithm, and the master executes the flexible traffic scheduling algorithm. Now FSS is basically based on the switch table concept, which is constructed when the scatternet is formed. Now each bridge node uses a switch table to direct switch between the multiple Piconet. As we know, the bridge node acts as a middle point, or we can say it acts as a node between the two or more than two Piconet, which forms one scatternet. So whenever the scatternet is get formed, first of all the switch table is get formed, and by using this switch table it is possible to perform the FSS scheduling algorithm. Now to avoid the bridge conflicts, a master polls a bridge node only at those slots when the bridge node is known to be synchronized to the Piconet controlled by master. So in order to avoid the conflicts between the node, it is not necessary that only one node acts as a bridge for the Piconet. There are number of nodes which can act as a bridge for the same Piconet. Therefore, to avoid conflicts between them, the master polls bridge only for those interval, or only for those duration of time when the bridge node, or we can say the bridge nodes which are acts as a slave for that particular master also, is known to be synchronized with the Piconet. Each master employs a flexible traffic scheduling algorithm to schedule both, that is dedicated slave and the bridge node. So master performs flexible algorithm for two different types of node. First of all the slaves of that master, and second is for the bridge of that master. The switch table can dynamically adjust it based on the traffic load so as to improve the system performance. The bridge table is not a fixed type of table, it is dynamically changes because as depending upon the traffic requirement, depending upon the data transfer on the network, the traffic is get changed, and due to which it is possible that the switch table is dynamic in nature. Compared to some static scheme, FSS can significantly improve the system throughput and reduces the packet transmission delay. As the requirement of the traffic changes dynamically, therefore the switch table is also get changes, and because of that it is possible for the system to provide maximum output, that means the maximum throughput, at the same time reduction in the packet latency, that means the reduction in the reception delay of packets. Now the next type of scheduling is nothing but credit-based scheduling, that is CBS. So it is based on the Bluetooth sniff mode that defines presence of point for each inter-Piconet link at which the communication may start. As we know, the Bluetooth device can operate in 4 different modes of operation. In active mode, it performs the actual data transfer, and the remaining 3 modes, that is hold, park and sniff mode, are the modes in which the device undergoes into the power saving mode. So this type of algorithm, that is the credit based scheduling, is basically used for the sniff mode of the Bluetooth device. Then the rationale behind this point is to enable each device to quickly determine whether the peer device is in the same Piconet. So in order to determine the presence of the device, this type of algorithm or this type of scheduling method is used. If so, the communication may start between the devices, otherwise another presence point may be tried without having much bandwidth. So if it is possible to perform the communication, or if it detects the presence of the device, then the communication is get started between the device, or if it does not detect the presence of device, then in that case another presence point is get identified by using a low bandwidth requirement. Now the length of particular communication period is not predetermined, as the data may be dynamic in nature. Sometimes the long data is required to be sent, sometimes a short data is required to be sent. So based on that, or based on length of the payload, it may possible that the communication period is not predetermined. It depends on the current link utilization and amount of data to be exchanged. As we just discussed earlier, depending upon the length of payload, depending upon the length of data, based on that the communication period is get vary. At the same time, based on the link utilization also, the communication period is get vary. Sometimes the link may get free for the data exchange, or sometimes it may finds the link is busy, so in that case the device has to wait for the period of time. So based on this scenario, the communication period is get changes. The presence point and the dynamic length of the communication period may be mapped directly into the sniff node, requiring little or no change in the current Bluetooth specification. So mapping between the dynamic communication period and the presence point takes place onto the sniff node, so that it is possible not to change the Bluetooth specifications. The communication schedule is then determined online for each communication period. So based on the communication period, which changes with the data and which changes with the utilization of the link, based on that the communication schedule is determined. The next type of algorithm is nothing but the local adaptive algorithm, which is denoted by LAA. While CBS uses the sniff node, LAA uses the hold mode. So these two modes are basically the power saving mode of the Bluetooth device. So CBS, that is credit based scheme, uses the mode which is called as sniff node, and the LAA uses the hold mode of the Bluetooth device. The primary difference between these two modes is that the duration of the hold period is not set every time the slave is placed in the hold mode, whereas the parameters that sniff mode are set once can be reused for the main interval. So here we can say when the device enters into the hold mode, it is not possible to determine the duration of the hold period, but where in case of sniff mode, once the parameters get decided, then the same parameters can be used for the multiple interval of time. Therefore, hold mode requires repeated negotiation that waste at least a pair of slots, while the sniff node requires a single negotiation. As in case of sniff node, once the parameters are get decided, then it is possible to use the same parameters for the multiple slot or for the multiple period of time. And therefore, negotiation is required to be performed only once during the communication, and that requires only single slot for the negotiation purpose. But that will not happen in case of hold mode, as the hold mode is get changes very dynamically, and therefore the repeated negotiation, or we can say the parameter get also changes dynamically, and because of that the repeated negotiation is required, which waste sometime 2 or more than 2 slots. The minimum wastage slot value is considered as a 2 slot or a pair of slot. Therefore, the sniff mode may be more suitable for the steady traffic, whereas bursty traffic may be better supported by the hold mode. So when the traffic is steady, then there will be no requirement for calculating or computing the parameter again and again. So in that case, the sniff mode is suitable. But when the traffic is variable in nature, or when the traffic, we can say if it is a bursty traffic, then in that case we require to use the hold mode, as it requires a repeated negotiation based on the traffic requirement of the network. The LAA manage scheduling mechanism of the bridge by determining the duration of the bridge activity in the different Piconet, so that the delay the packets requiring Piconet routing can be reduced. So on the basis of how much the bridge get involved in the communication of each Piconet, based on that it is possible to determine the bridge activity. The algorithm adapts to vary load by utilizing information regarding its queue to the different master, and also by using the information transferred by the master. So basically it adapts the variable loads which uses, or by utilizing the information required for its queue purpose, and also by using the information that is transferred by the master. Now the next type of scheduling algorithm is nothing but jump mode based scheduling algorithm. So this mode basically includes a set of communication rule that enables efficient scatternet operation by offering a great deal of flexibility for node to adapt its activity in the different Piconet for traffic condition. So in order to have a compatibility according to the various traffic present in the various Piconet, or various traffic present in one scatternet, this mode is specifically define a set of communication rule that allows the efficient use of scatternet operation. Using JMP mode, the bridge node divides the time into time window and then signals about which Piconet it is going to be present for each node of these windows. So here in case of jump mode based scheduling algorithm, the jump mode is used in which the bridge node basically divides the time duration into different time window, or we can say a time slot, and then the signal is passes through that particular time slot for each window. Now that time window are basically a pseudo-random length to eliminate the systematic collision and therefore avoid the starvation or live lockup problem without need of scatternet coordination. So here the variable value of timing window is decided, or we can say the random value of time window is get decided, so that it is possible to avoid the starvation and the lockup link problem, as well as to avoid the systematic collision. Besides enabling scatternet operation, the jump mode may also enhance the other aspects of the Bluetooth, such as low power consumption. As we know, the main important parameter of the Bluetooth is the power consumption, as most of the devices used in the Bluetooth network are the battery operated and the portable devices. Therefore, to have the longer battery life, it is very much important that the device must consume, or we can say the network must consume less power. Therefore, this jump mode operation, or we can say the jump mode algorithm, also concern about the low power operation of the Bluetooth network. Now let's compare the various algorithms that we have studied. So here we are comparing the algorithm on the basis of various parameters, and the parameters are dynamic, ideal, quality of service provided by the algorithm, then which topology is used by scatternet for developing the algorithm, then what are the modified Bluetooth specification, then feasibility, then computational complexity, and the best technique for the particular scanning method. So let's start. So here first of all, to check whether it provides a dynamic nature or not, the dynamic used as a first parameter. In case of DSSS, no dynamic is used, while the others are dynamic in nature. The others are nothing but PCSS, LCS, FSS, LAA, CBS and jump mode algorithm. Then ideal condition is supported by DSSS, it is not get supported by any of the algorithm. Then quality of service is provided only by using FSS and by using CBS, and others do not provide that much or expected quality of service in the operation. Then scatter-net topology. In case of DSSS, we can use any scatter-net topology. Similarly, in case of PSSS also any scatter-net topology can be used, but LCS most operate efficiently in case of loop-free network topology. Then the others like FSS, LAA, and CBS along with jump mode can use any type of scatter-net topology. Now modified Bluetooth specifications are get required only for LCS and jump mode, while others like DSSA, PCSS, FSS, LAA, CBS do not require modification in the Bluetooth specification. Then the computational complexity is very much high in case of DSSA and LCS algorithm, and it is low in case of PCSS, then LAA, then CBS and jump mode, whereas the computational complexity is very low in case of FSS algorithm. Then feasibility, the feasibility is get provided, or we can say the algorithm like FSS, LAA, CBS and jump mode are considered as the most feasible algorithm, whereas the DSSS and PCSS and LCS are not feasible, or they do not support the feasibility. Then the best technique used for DSSS is nothing but the graph theory. For PCSS, it is pseudorandom technique, where the equal share is provided to all the slave, or polling can be done in the pseudorandom sequence. Then in case of LCS, the appointments are used in order to provide the polling sequence. Then FSS uses a switch table method at the node side, or we can say the switch table is present on the bridge node. Then LAA uses the hold mode, whereas the Creditbed system uses the credit scheme, and jump mode uses the jump mode technique. So these are the basically suitable technique for each of the scheduling scheme. So this is how we can compare the various type of scheduling algorithm. Now next we are going to see how to select the bridge. So in Bluetooth, large ad hoc network are formed by interlinking individual Piconet to form a scatter net. We know that when two devices connect with each other, they form one Piconet. In one Piconet, maximum 7 devices can be connected to a master, but when one or more than one Piconet get connected with each other, they form a scatter net. So the ad hoc network is basically formed in case of Bluetooth by connecting or by interlinking the individual Piconet so that they can form a scatter net. The scatter net are formed by sharing one or more than one slave, which is called as bridge node. That means when the Piconets get connected with each other, a common node or common slave is present between both the Piconet, and that slave or that node is called as bridge node. So it is not always necessary that only one node is acts as a bridge node. One or more than one node can be used as a shared node or a bridge node. So that bridge node, or when the scatter net are formed by sharing one or more than one slave in time division multiplex system, whereas the bridge node shares their active time period between the two Pico node. So whenever the bridge node is get formed, it is get formed on the basis of TDD, that is time division multiplexing technique, and that shared node, or we can say that bridge node, shares its active time to both the Piconet. So theoretically, the bridge can be a master in one Piconet and slave for the other Piconet, or slave in the both Piconet. It is not always necessary that the bridge required to be a slave. It can be a master of one Piconet, or it can be a slave of other Piconet, or we can say it can be a slave in both the Piconet. Now in practice, most current research consider bridge is in slave configuration only, as having bridge to be master in one Piconet will result in this Piconet being ideal every time the bridge in some other Piconet. So theoretically, it is possible that to consider a bridge node as a master of one Piconet or bridge node as a slave of other Piconet, but practically when we implement the network, it is not possible to perform such type of things. Only we require to consider bridge node is acts as a slave for Piconets only, because when the bridge acts as a master for Piconet, then sometime it may possible that it considered as a ideal every time when the bridge in some other Piconet. That means when bridge performing some operation with other Piconet, then one particular Piconet assume that the bridge is in ideal condition and the network operation may not get performed. The bridge having the responsibility of the switch buffering, then incoming data packets, then switching to another Piconet, and relay buffered packets to the new master. So basically it is used for transmission and reception of the data. Then it is having a responsibility of the switch buffering, where it receives the data packet from one Piconet, buffered it after receiving, and then transmitted to the next Piconet, or we can say transmitted to the new master. This means they always transmit, receive, or switch between the Piconets. So as it is considered as a shared node, therefore they are responsible for sharing of resources or sharing of information between the two Piconet. Now for selecting bridge, we require to consider one protocol that is called as energy efficient protocol. As we know, most of the devices used in the Bluetooth network are portable and handheld devices, and they are battery operated. Therefore, it is very much important that the energy conservation or power conservation of the network required to be considered as an important parameter. As the devices are battery operated, it is important to have a longer battery life so that the device or the network can perform in efficient manner. So for selecting bridge, we require to consider one criteria that is called as energy efficient protocol. The first scheme is a simple energy efficient protocol, that is E2P, in which the master decide on a set of nodes that are designated as a prospective bridges. The master then chooses two nodes to function as a bridge. These nodes are typically best in terms of computing and energy resources. So it is the responsibility of the master to select a nodes which acts as a bridge on the basis of the computing facility and on the basis of the energy resources, so that the master requires to select only those bridge which are energy efficient, that means they consumes less power. The master then tries to distribute the traffic among the two nodes which are selected by master on the basis of the computing and energy resources, sending packets to two bridges in round robin fashion. And we can also use other types of algorithm like ElWR, or we can use PlWRR algorithm rather than using a round robin algorithm. The bridge buffer the incoming data packets and then switch at the same time for the predefined sniff period previously agreed upon masters of both Piconet through the any bridge negotiation protocol. So here the sniff period is get decided by the master, which is predetermined by using some negotiable protocol, and the bridge buffers the incoming packet for the sniff period amount of time. This simple division seems to work well, improving energy saving about 43%. So the main aim of the protocol is to serve, or we can say to save the energy, and here we can simply save the energy, which is about 43%. So here we can see the graph, or we can see the representation of energy consumption in single bridge versus E2EP. So here we can say that x-axis consists of data bytes received and y-axis shows the energy consumed by bridge node, and as the data packet received get increased, the energy consumption is also get increased. Next, we require to consider another point that is related to traffic engineering. So now in case of large number of connection to be supported by the network, in one Piconet as we can connect maximum 7 nodes to the one master, therefore, and when number of Piconets get connected to each other, they form a scatter net. So in that case, large number of connections are required to be supported. Either it increases the delay or it simply blocks the incoming traffic. So as the number of connection is get increases, it may possible that the delay or the data transmission latency is get increases, which results into the occurring or transmission delay of the packets, and or it can simply blocks the incoming traffic. The bottom line of this problem is the lack of traffic engineering techniques in the current Bluetooth. As the current Bluetooth do not having the traffic engineering techniques, therefore it is not possible to overcome these two problems. That means the increase in the latency, and second one is the blocking of incoming traffic. So the traffic engineering has been shown to be extremely useful for the internet by efficiently transferring the information from source to any arbitrary destination with the control routine function that performs the traffic through the network, or that can route traffic through the network. So by using traffic engineering, it is possible to efficiently use the traffic on the network, or it is possible to efficiently maintain the traffic on the network, so that the latency problem as well as blocking of incoming data problem can be avoided. A systematic application of traffic engineering helps in enhancing the QoS delivered to the end user and aids in the analyzing this result. So if we use a proper techniques of the traffic engineering, then it is possible to provide a better quality of service to the user and make the network use efficiently. So traffic engineering basically suggests both demand side and the supply side policies for reducing the problem of network traffic and for improving the quality of service delivered to the network user. So basically the demand side policies restrict the access to the congested resources and dynamically regulates the demand to the overloaded condition or control the way the data is routed to the network. So here, as we know, the resources get shared by the network, so it may possible that one resources is get congested with most of the requests. So by using the demand policies or by using the demand side policy, it is possible to restrict the access to that particular resource. So by using this method, it is possible to reduce the network overload condition, or it is possible to provide the improved quality of service to the user, and we can also control the way that the data is routed to the network. Now the second type of policy is nothing but the supply side policy, and supply side policies basically deals with the network capacity to better accommodation of the traffic. So depending upon what type of traffic the network received, accordingly the capacity of the network is get decided. Next, we are going to consider the PRS, which stands for pseudo role switch. So PRS will not require any change in FSH, as this scheme keeps the Piconet synchronization on the previous Piconet parameter. So here, rather than changing the parameter of the Bluetooth or rather than changing the parameters in the FSH, the Piconet synchronization is achieved by using the previously set Piconet parameters. Demand side traffic engineering are suggested by categorizing the request based on the type of data that is being transmitted. So what type of data is transmitted on the network, how much amount of data is get transmitted on the network. So by categorizing this data, it is possible to perform a traffic engineering on the demand side. For example, we consider audio data which has a critical latency requirement. Telnet traffic needs quick response time, then FTP traffic needs reliable communication. So these are the basically requirements of the traffic. If we are considering audio, then here the critical latency is considered as a requirement. In case of audio, it is not permitted to provide delay in the data communication. Now when we consider the telnet traffic, then it requires a quick response. Then if we consider the FTP traffic, then it requires a reliable communication. So based on what type of data we are transmitting on the network, the data is required to get categorized on the basis of the various requirement. The priority is given to those connections which have the straight QoS requirement, while at the same time supporting less constrained communication. So the requirements which are more critical given the highest priority, and the requirements which are less critical given the lowest priority, and depending upon the QoS requirement also the categorization is get performed. Now the graph which we have seen is nothing but the graph between the data bytes received versus the actual information transmitted over the network, where the FTP connection is followed by the telnet connection and telnet is followed by SOC connection. The delay characteristics of any network reveals that this PRS scheme managed to reduce the delay to almost half of its original value. So by using PSR, it is possible to reduce the delay occurs in the network, or we can say delay occurs in the data transmission, and therefore it improves the quality of service supported by the network. Then here we can see the procedure which is used for pseudo role switching of the master. So from the diagram we'll come to know that first of all, role switch request is sent from slave to master. Then the request, when get accepted by the master, it will send an acknowledgement back. The time consuming steps are avoided by the pseudo role switching and achieve the maximum throughput improvement. So in PPR, the Piconet is get divided when the need for bandwidth cannot be fulfilled by the current structure. So when we want to transmit a large amount of data, then sometime it may possible when a large amount of data is required to be sent, then in that case it may possible that the bandwidth cannot be fulfilled by the current structure. So in that case the PPR is used. The decision of partitioning the Piconet is taken in such a way that the device which are consuming most of the bandwidth and does not involve in the current master are get separated. So here the partitioning is done on the basis of how much involvement of the device is in the communication. So the devices which consumes more bandwidth and the devices which do not involve in the communication, those devices are get separated and the partitioning of the Piconet is achieved. This type of partitioning should not last forever, and rejoin the Piconet should be made as possible as soon as the traffic in one of the Piconet ends. So on the basis of how much traffic is going on onto the network and how much partitioning is done, on the basis of this temporary partitioning is required to be done, and this type of partitioning should not last forever, and rejoining of the Piconet is required, because when the traffic in one Piconet get ends, the other Piconet may acquire with the heavy traffic or heavy load. Certain threshold value should be maintained to avoid continuous partitioning and rejoining upon every connection arrival and termination. Now, such decisions can be taken if the master knows the negotiated QoS parameters while establishing all previous connections. So if the master is aware about the QoS requirement or QoS parameter of the previous connection, then it is possible to perform, or it is possible to set the certain threshold value. So by using this threshold value, it is possible to maintain the avoidance of the continuous partitioning, and it is possible to maintain the rejoining of the network or rejoining of the Piconet. The performance of PPR under overload condition by dynamically generating FTP connection request has been evaluated. So the performance of the PPR is get evaluated on the basis of the dynamically generated FTP connection request, and that connection request helps to evaluate the PPR performance under the overload condition. So this is what about the various algorithms which are used for performing the inter and intra Piconet scheduling on the basis of the requirements of the network, on the basis of the application in which we are using the network, and the applications for required by the user. On the basis of these parameters, it is possible to change the algorithm. So I hope you understand this topic of intra and inter Piconet scheduling. So thank you very much for watching this video. Stay tuned to Ekeeda, subscribe Ekeeda. Thank you.